We're going to go slow. What is the secant? What is the tangent? What is the normal? Ready? I'm going to tell you. Hopefully you remember from physics, but if not, no big deal. This is a graph, and I'm just going to draw a random curve. That's just a random curve. A secant line goes through 2 points, like so. That is a secant. Yay or nay? Yeah, it's supposed to be a straight line. I can't draw straight lines. What is a tangent? A tangent, it's this one here in green, goes through 1 point. And a normal is perpendicular to the tangent. I didn't do it perfect, but that's fine. I mean, the normal is perpendicular to the tangent. So it should be looking 90 degrees, but it doesn't. And the tangent should be going through one of the points of the red curve, but it doesn't look like it at all. All right. What is what? What is what? Imagine you have a volleyball. Sorry. Imagine you have a tetherball or a volleyball attached to a string. Yay or nay? Okay, imagine that you are spinning with this volleyball. Are you imagining yourself spinning? Yeah. All right. When you let go of that volleyball, it's going to go off in a tangent from physics. So here's what I'm saying. Chavez, what are you saying? So here it is, bird's eye view. This little dot is you, and you're spinning. That's a string, and here's the volleyball. And you're going counterclockwise. Not even close to the center. You make it big. Oh, that's pretty good. Okay. If you're spinning counterclockwise, you guys ready? If you let go of the ball, so let's say you're right here, and you let it go at this moment, the ball's going to go, you're spinning counterclockwise. The ball's going to go that way. That means, that's what you call it went off on a tangent. Cool? So that's why we draw the tangent like that. If you were to let go of the ball right here at that moment, the ball's going to go that way because you're spinning counterclockwise, right? If you let the ball go, if you let the ball go right here at that moment, it's going to go that way. Those are all tangents. Cool or not cool? Yeah, there it is. You got it. And then what's a secant? So a secant goes to 2 points. That's a secant line. Hopefully you remember from geometry. No big deal if you don't. We're going to do this over and over. Yay or nay? Don't worry about that. Don't worry about those. Don't worry about those. Okay. Are we clear with tangents, secants, and normals? Okay. Yeah, all we did was this, guys, in case you're real quick, really fast. What's a tangent? A tangent goes through a point like this. What's a secant? A secant goes through 2 points like that. And then what's a normal? A normal is perpendicular to a tangent. Hey, focus, so let's focus. Don't worry about that. Let's focus on this. Don't worry, I'm going to give you time. Don't worry. Don't be mad. Okay, well, now I'm going to do this real quick. I want you to have your A game, miss. Find the average rate of change of f of x equals x cubed minus x over the interval 1 to 3. Rate of change, guys. You guys have been doing this since we were in junior high. No, we have. If I want the rate of change, remember, this is an x value. X equals 1, x equals 3. If I want the average rate of change between 1 and 3, all that means is this. F of 3 minus f of 1 divided by 3 minus 1. You guys have been doing that since what grade? Right? At least, I would say 7th, maybe 8th. Pre-algebra, maybe algebra 1. So here we go. I need f of 1 on the side. I'm going to go f of 1 equals 1 cubed minus 1, which is 0. And then I'm going to go f of 3. 3 cubed minus 3. So 3 to the third power, 3 times 3 is 9, 9 times 3 is 27. 27 minus 3, 24. So I'm going to go 24 minus 0 divided by 2. The average rate of change is 12. Is everyone okay with that? Nothing crazy, right? Very simple. Okay, let's keep going, guys. Don't freak out. Don't freak out. It says use points P and Q to compute the average rate of change and the slope. Notice that they use the word secant. Secant line PQ. Do you see that line? Notice that it goes through 2 coordinates. If I want to compute the average rate of change, what are they looking at here? Number of flies and time of days. So it looks like it's looking at the number of flies per day if I compute the average rate of change of that. So you're just going to do it like you did in Algebra 1 and Algebra 2. So I'm just going to go change in y over change in x. What coordinates am I using? I'm using the points 45, 340, and I'm using the point 23, 150. I'm going to go 340 minus 150 over 45 minus 23. I take my calculator out. I'm going to use the fraction feature, alpha y equals, and I'm just going to type it in. 340. I already forgot. Was it minus 150? And then what did I have in the denominator? 45 minus 23. Enter. And I get that. I don't want that. I want it to be a decimal. 95 over 11. 8.636363363 repeated decimal. Yeah, that's fine. 8.63 line repeats. And if we have units, in this case we do flies per day. How are we feeling? All right.
Oh, yeah. Are we gonna like what's it called? What's it called? Like the thing you do in math that money like round down.
Truncating. So 8 flies per day, 9 flies per day, depending on what the experiment is. I actually took the question out. I just wanted. Yeah, don't worry. We'll figure this out. All right. So here we go, guys. Ready for this question? It says the function f of x, and I have some function, is graphed to the right with some secant lines. Determine the slope of the secant line of f for each of the intervals indicated in the table. Find the slope of the secant line f on the interval 3 to x2 for each value of x2 shown in the table. Write your answers as decimals. Okay, no big deal. So what they're trying to say is this. What's my slope between 3 and 4? What's my slope between 3 and 3.1? What's my slope between 3 and 3.01? What's my slope between 3 and 3.001? So they're trying to, I don't know, I did a bad job. Next time I'll make them real thick. Do you guys see all these little colors there? Those are supposed to be secant lines. And as I get closer and closer to the number 3, I'm supposed to be getting closer and closer to a tangent line. Like, you know what I mean? Like, what's a tangent slope at 3? Because you can't predict, you can't. Well, I mean, you can make a prediction using the secants. Notice that my interval is getting closer and closer to 3. Do you guys see that? So I'm going to go, and I put a lot of white space on purpose. So I'm going to do this. Here we go. I'm going to go my slope between 3 and 4. And we're going to let the calculator do all the heavy work for us. So we're not going to, everyone take out a calculator, guys, because I need you guys to practice with it. Everyone take out a calculator. I need you guys to practice. I'm going to go. Here we go. I'm going to do this. And don't worry, we're all going to follow along with the calculator. I'm going to go f of 4 minus f of 3 divided by 4 minus 3. And I'm going to write what that slope is. So here we go. I'm going to take my calculator, and I'm going to write the equation that I have. Well, first I'm going to fix my mode. Click on mode and go to, I want decimals. So where it says answers, put, instead of auto, put DEC. All right, now we're ready. Go to y equals. What was my equation? X, 2x squared. 2x squared minus 6x minus 70. That was my equation? Okay. Go to your home screen. So put this in y1 first. And all of our calculators should be 84, so all of them should be the same. All right, go to my home screen. In the home screen, push alpha, y equals, enter. And you should have a little fraction. You can also get that little fraction by pushing alpha link, I believe, or alpha something. All right, here we go. I'm going to take out where my y1 is at. So I push alpha, trace, and you have a list, y1 through y0. Do you guys see that? Push enter for y1. Open a parenthesis, and type in the number 4 in there. Close it, and I'm going to go minus, and don't worry, I'm going to repeat it again in case. Alpha trace y1, close it, and I'm going to put 3 in there, like that. Does anyone need help on how we did that? You need help? Okay. Yeah, we've got to make sure we got this, guys.
I quite like the calculator. Because I used to use this a lot in middle school.
Anyone else?
Wait,
Oh, you got it.
I just never.
Push that button. Push that button. Yeah, push that button.
I remember my teacher had like all our notes were like all the breaks. It wasn't okay. That's not a lot.
Yeah, you're winning, man. Give me up. All right. Push alpha trace. Oh, let's push. No, I'll wait till that one. For my over one, yeah. All right, guys, here we go. In case you're wondering, Chavez, what is the calculator doing? All you're asking the calculator to do is calculate your y value when the x is 4 and the function's in y1. Calculate the y value when your x is 3 and the function's in y1, and dividing by 4 minus 3, which is just what? 1. You can just type 1 in there. Push enter. You see that number 8? Type it in. Right here. Secant slope 8. Write it in, sorry. Now we're going to do the same steps again, but you don't have to work really hard, guys. You're going from 3 to 3.1. This is an interval. So f of 3.1 minus f of 3 over 3.1 minus 3. Do you guys see what we're doing? I'll slow down. I'm only changing the 3.1 there, right? So I already have it here. Just scroll up, push enter, and then just change the 4. Now, don't just put 3.1 in the 4, guys. You got to push the insert button. Second, insert 3.1. And then to delete the 4, just put delete. See? I'm going to do it again. Check it out. Second, insert. It's in blue, INS. 3.1. And delete. You could also just put 3 divided by 0.1. Push enter. What'd you get? 6.2, hopefully. All right, put it in there. 6.2. 6.2. Now we're going to get the slope between 3 and 3.01. So I'm going to go f of 3.01 minus f of 3 divided by 3.01 minus 3. Let's see what that is. There's not sadness. 6.2. That's what I got for that one. Here we go. I'm just going to put in a 0.0 in there. Second insert, 0. So that one's good. Second insert, 0. So now we're good there. Enter. I got 6.02. Maybe, probably. Last one. F of 3.001 minus f of 3 minus 3.001 minus 3. I'm going to insert an extra 0 in there. If you don't have a... This is my favorite calculator, guys, because it can let you guys be super fast. The TI Inspire is also a good one. If you already have an Inspire, don't buy another calculator. But if you don't have an Inspire, I would buy this. Whatever calculator you feel most comfortable with, it's just a tool. Yeah, I can be really... You can be really fast with the TI-84, like really fast. Second insert 0.
That's how you do it.
What are you talking about? Like,
really like having to choose because you know how you know how whenever you like delete one, it has to be the same amount of characters as the next one. So if you wanted to add another 0, you have to like do the whole thing over.
So you've been doing the whole thing over?
Yes. Because I'm like, there's no way I can do this. I didn't know you could like insert another character.
Yeah. Yeah. See how I just do this? So let's say I have like some random digits or whatever, right? And let's say I want to replace that 5 with like a 7. So I push second insert and I put another 7. And then to delete the 5, I just put delete. See how I did it? In case you're wondering, too loud? In case you're wondering, Chav, when am I gonna be using this type of stuff? Maybe you won't be using this technology exactly the way we're doing it, but who's the one that's gonna be calibrating the medical equipment? You guys. And when you calibrate your medical equipment, what do you think you have to do? You have to go through some set of procedures like what we're doing right now. Okay. Well, are you gonna reference the manual every single time?
Probably. Even if I knew like 100%, I'd probably still reference the manual every single time.
All right, here we go. Oh, you did something wrong? I'll go check it right now.
Parabola.
Take a guess. What do you think the slope is going to be when x is 3 for the tangent line? It looks like that tangent line there, it looks like it's that one in red. It looks like that tangent line in red has a slope of 6. Does that make sense? Yes, ask. No, I learned that by finding my slopes of my secant lines as I got closer and closer to 3.
It's like the limit.
Do you know what I mean? Yeah, it's exactly like the limit. Cool. How do we feel, guys? Do you think we can do a few more? Just example, just this page, because that's actually like the heart and the butter of it.
The heart?
The butter of the tortilla.
Oh, I was like, girl, what
Huh?
are you talking about?
Delmer closed it. Yeah, I don't like it closed, but maybe we're being too loud. Open it a little bit. All right.
It's not, but I like
10:30. All right, here we go. You guys ready? All right, guys. This is a game part that we need real quick. Look what this question says. It says, right up the cream. It says, find the slope of the parabola. Oh, sorry. I just thought it was one of these two. 3. Find the slope of the parabola y equals x squared at the point 2,4. Write an equation for the tangent line to the parabola at this point. What do you notice? I have a parabola, and it wants the slope of this tangent line, but I only have 1 point. In all your life, have you ever found the slope of anything with just 1 point? But we're about to. Don't worry, we're gonna go real slow. I'm gonna first talk theory, and then we'll do the calculation. Ready? So here we go. First, draw, and let's exaggerate quadrant 1. And I'm gonna exaggerate x squared. I'm gonna say that this is x squared like so. Are we still okay? All right. So I'm going to say that at this coordinate, all right, guys, focus. At this coordinate, I'm going to say that is x coordinate 2. And because this is x squared, 2 squared is 4. Yes or no? Okay. I'm going to choose another coordinate way over here. And I'm just going to say this distance here is just h. Don't worry. So this coordinate here is f of 2 plus h. Oh, hold on. That's their y value. It's okay. You don't have to erase it. You can just move. You can just do this. 2 plus h for your x, comma, f of 2 plus h. And if you want to, so we can be like the same. I can say this is f of, I'm doing it again, 2 comma f of 2. These are the same. Are we okay? All right. What do you know from Algebra 2 on how to find this slope? And I'm going to put S for secant of these 2 points. So let's say, look, you see this blue line that I'm connecting there? So I want the slope of that blue line. It's a secant line right now. So I'm going to color code it. Slope of that secant. Isn't it just y2 minus y1 over x2 minus x1? So I can go f of 2 plus h minus f of 2 over 2 plus h minus 2. Is this making sense right now? All right. If I told you what h was, you'd be able to figure this out really fast, right? But I don't want the slope of that blue line. I want the slope of that green line right there. Don't worry, I'm going to go really slow, guys. Super slow. Well, because I don't want to freak anyone out. You guys ready? Okay. Do you agree that if I make h approach 0, I will be right at that green line? Yeah, let me say it again, and I'll go over here. Do you agree? This is my slope of the blue line, yes or no? If I give you an h value, you can calculate it really quick. Just put numbers in. If I tell you that h is 1, then like, oh, that's just f of 3 minus f of 2 divided by 1. 3 minus 2. If I make h approach 0, wouldn't that give me my green slope? If I make h approach 0, because that means that I'm right on that point. Do you see that or not? No? Yeah. Like right now, the h is like 1. If I make h half, I'd be halfway. If I make h equals like 0.1, I'm like really, really close to it. But if I make h approach 0, I'm right on that point at 2, 4. So the 2 is 0. Well, if h is 0, then I would be right at 2. Right? And that would give me my green slope, right? Yes or no? Okay, so that's a limit. Because, let me tell you why. You cannot calculate a slope unless you have 2 coordinates. But I don't have 2 coordinates. I just have 1. So here's how I'm going to write it. I'm going to write it in green. I'm going to go slow. I want the limit as h approaches 0 of f of 2 plus h minus f of 2 over, and then the 2 plus h minus 2, the 2's cancel out, right? Over h. Yeah. Are we okay with that? Yes. You see how in the blue here I have 2 plus h minus 2? Notice that the 2's cancel out. Are we okay, guys? Here we go. On the side, I'm going to go and find what f of 2 is. You already know it. F of 2 is just 2 squared, which is just 4. Are we all right? Now I need f of 2 plus h. F of 2 plus h is parenthesis 2 plus h close at squared. So expand it. 2 times 2, 4. 2 times h is 2h, but you're going to have how many of those? 2 of them, so 4h. And then h times h squared. Have I confused anyone? All right, so here we go. I'm going to write limit as h approaches 0 of 4 plus 4h plus h squared minus 4 all over h. Before you start answering your answer, let's zero some stuff out. What happens to those 4's? Now that I've canceled those out, can I factor out an h in the numerator? So I'm going to go ahead and do one more line, guys. Limit as h approaches 0. Here's my h factored out. 4 plus h over h. The h's cancel. Do you guys see that? This h here approaches 0. And what is my slope? The slope of that green tangent line is 4. How do you feel?
Going back. Wow.
Yes, ask. Well, let me get out of this really quick. No, we just had h. Oh, the 0 came from h is approaching 0. Oh, good question. Keep asking. Yes. Because I want the tangent line for the green one. So in order for that to happen, I need h to be 0 so I can be right at x equals 2. In case you're wondering, no one's asked, h is like delta x. No one's asked. I was waiting for someone to ask, but that's fine. Delta x. Cool or not cool? Don't worry, we're going to do a whole bunch of these. I know, miss. I know, we're good. I got my slope. I still haven't answered the question. What did they want? The equation. So how do I find an equation of a line? Y minus y1 equals slope x minus x1. That's a slope. That's what? Slope, point slope form. Yes. F of 2 equals 2 squared, which is 4. The equation is f of x equals x squared. So 2 comma f of 2 is the same as saying 2 comma 4. Did that answer your question or not? Give me more questions, guys. I can't read minds. Tovar, hit me. I mean, don't hit me, but like hit me. All right, here we go, guys. Here's by the way, you can leave it like this. This is a beautiful part about the AP Calculus exam. Do I have a point? Do I have a slope? You can leave it like this. Y minus 4 equals, the slope has to be 4, or it is 4, x minus 2. Leave it alone. Leave it alone. Especially if you're prone to mistakes. Yes, you can leave it alone right there. Yes. Point slope form. X minus x1. The point is 2, 4. Yay or nay? All right, here we go. So now we're going to practice. You guys ready? Letter A says, write an equation for the tangent to the curve. Oh, you know what? Don't you guys want to see how this looks in Desmos? All right, look, guys. Look how beautiful this is. Look, man.
What's your background, Tom?
Electrical engineering? What?
No.
Oh. I don't know my background.
Your screen background. Your desktop
Oh. Sorry, miss.
Bro, it's the way that I thought. That's the way you know engineering is. I read a picture of like
Sorry. I don't know what's going on. All right, guys. All right, we're good. Settle down. We're good, guys. We're good. All right, here we go. Here we go. Look, guys. Let's see if this really does look like a tangent. You guys ready? I'm going to type in y equals x squared. So here we go. I'm going to go y equals x squared. And then on this one, I'm going to type that tangent line that I just gave you. What did I give you? Y minus equals plus or minus? Minus 2. Look at that. Does that look like a tangent?
Oh, period. We're so cheap for that.
Let me put the 0.24. It's coming back, guys. 2, 4. I don't know what's going on. It must be maybe my laptop is overheating or something. Look, guys, my 0.24, and I know I think it's my laptop's having issues now. 2,4 there, and look, that looks like a perfect tangent, like a beautiful tangent. Isn't that cool?
Yes, that's really cool.
All right, check it out. We're gonna do another one, and yeah, ask.
Where would we see that change in x on that distance?
Oh, you don't see the change in the slope is the instantaneous rate of change. You know what I mean? All right, here we go. My laptop might start going in and out, guys, because I can feel all the heat coming up. So if my face turns red, it's not that I'm shy or anything. It's just that all the heat from the laptop is hitting me. All right. Do you know? All right, here we go. I want the tangent line for this. And guys, it's so easy to become a robot. Can you pass the safety exam being a robot? Yes. I don't want you to be a robot, though. And I know, because the steps are the same all the time. So because the steps are the same all the time, you can become a robot and I don't know what I'm doing, but Chavez does this all the time, and I'm going to do it all the time, and that's how I get my right answers. Guys, don't be a robot. Try really hard. All right, here we go. I want a tangent line. I need 2 things. I need a point, and I need a slope. Yes or no? Yes. All right, let's get the point. So when x is 1, so I'm going to write f of 1 equals 4 minus 1 squared. What's 4 minus 1 squared? So I got my points. 1, 3. Are we still cool? Now I need my slope. Here's how I'm going to get my slope. My slope of the tangent is equal to the limit as h approaches 0 of f of 1 plus h minus f of 1 divided by h. Your slope will always look like that. y2 minus y1 over the change in x. Yes. 1 plus a little bit past it, y2 minus f of 1 divided by your delta x. It's always going to be like that. F of 1 plus h, if I tell you my slope at 3, 3 plus h. Okay. Are we okay so far, guys? On the side, I already have f of 1. On the side, you're going to go, what is f of 1 plus h? 4 minus, parenthesis, 1 plus h, close it, squared. 4 minus, expand it. 1 times 1 is 1. 1 times h is 1h. We're going to have how many of those? So 2h. H times h, h squared. Distribute the negative. 4 minus 1 minus 2h minus h squared. What's 4 minus 1? 3 minus 2h minus h squared. Are we still okay? All right, here we go. My slope of this tangent, limit as h approaches 0. And I'm going to write f of 1 plus h. 3 minus 2h minus h squared minus 3 all over h. Are we still okay? Stop me if I'm going too fast. Okay. What can I zero out? The 3's. Now that I have the 3, 0 out, I'm tempted to cancel out the h's, guys, but I don't want you guys to pick up bad habits. I'm going to factor out an h. So I'm going to write one more time. Limit as h approaches 0. Here's my h factored out. Negative 2 minus h all over h. What's going to cancel? Now can I do direct substitution? What is my slope? -2. I have a point and I have a slope. Can I get my tangent line equation?
Yeah.
Here we go. Y minus, what's my y value? 3 equals, what's my slope? -2, and then x minus 1. This is in point slope form. If you want it in y equals mx plus b, that's fine. I'm about to put this in Desmos to see if I can see how it looks. What's up, Salvera? H is approaching 0. Yes, because I want a tangent slope, which means I want delta x to approach 0. Always. So check it out. I go to Desmos. I'm going to type in my equation. And I don't know why it does that every time it gets... what's my equation? Y equals... 4 minus x squared. All right, so there it is. And I want my slope at what point? Was it 1, 3? And then here's my point slope formula. What is it? Equals negative what? And look at that.
Oh my God.
Does it look pretty? Look, it's going right through that point. That definitely 100% a tangent. Yay or nay? All right, I'm going to leave it because I think the next one just wants a normal. All right, so here we go. Let's see if you guys still remember. Don't worry, I'm going to be true. This is my last page. We're not going to continue after this. All right. Look at what this says, guys. Letter B. Write an equation for the normal to the curve. Is it the same curve that we've been working with? All right, look at your notes. Look at the first page. It's perpendicular to your tangent. That's what my normal is. What is my slope? Opposite reciprocal. Do you guys remember that? Well, whatever my slope is, opposite reciprocal. So what was my slope? -2. What is opposite reciprocal of -2? So I'm just going to go y minus 3 equals positive 1/2 x minus 1. Does everyone see how we did that? I'm sorry, say it again? Yes. This was my slope for my tangent. You're going to do opposite reciprocal of this. Why are you doing opposite reciprocal? Because my tangent and my normal are perpendicular. Does that make sense? Now check it out. Let's see if it really does look perpendicular, guys. I go to my Desmos, and I'm going to type the same thing. Y minus 3 equals, and I'm going to put a half. 1/2. Move to the right, and I'm going to put x minus 1.
Let's go.
Look at that, guys. Does that look perpendicular?
Yes.
Yeah. How do we feel? All right, I'm going to pass on activity. You're not going to be able to finish it today, but you can probably already start doing the simple problems like what's the average rate of change and find me tangent lines. You don't even worry about the rocket problems yet. Cool? We will continue this tomorrow. 6. So it says, example 6, it says find limit as h approaches 0 of f of t plus h minus f of t over h for the function f of t equals 2t squared minus 1 at t equals 2. Interpret the answer if f of t represents a position function in feet of an object at time t seconds. So let's just calculate that. So here's what we're going to do. I need to know what f of 2 is, right? So f of 2 is 2 times 2 squared minus 1. 2 squared is 4. 4 times 2 is 8. 8 minus 1 is 7. And now I need to know what f of 2 plus h is. 2, parenthesis, 2 plus h close at squared minus 1. So let's see what this is. 2, parenthesis, 2 times 2 is 4. 2h plus 2 times h is 2h, but I'm going to have 2 of those, so plus 4h. And then h times h is h squared minus 1. I still need to distribute that 2, right? So here's what that is. I get 8 plus 8h plus 2h squared minus 1, which is finally 7 plus 8h plus 2h squared. I know, guys, I'm sorry that I went from one to the other. Are we okay? All right. I am calculating this right now. Limit as h approaches 0. And then I have 7 plus 8h plus 2. Did I mess up? Oh, 2h squared. Minus, that's f of 2 plus h. Minus f of 2, which is 7, all over h. Have I messed up? Okay. So here we go. I'm going to zero some stuff out. So let's zero out some stuff. The 7s, 0 out. Can I factor out an h in the numerator? So I'm going to factor that out. I'm going to write limit as h approaches 0. Here is the h factored out. 8 plus 2h. Close it over h. What can I cancel? H's. What is h approaching? So this is just going to be 8. And I'll go ahead and put it here with a green arrow. That's approaching 0. Are we feeling okay? All right, so now look what it says. Interpret the answer if f of t represents position function in feet of an object at time t seconds. What do you think this 8 means? Eight feet per second. It represents speed, 8 feet per second. So in case you're lost, in case you're 100% lost, remember that what we found is an instantaneous rate of change, or a tangent slope, right? If you find a tangent slope on a position time graph, it's going to give you, well, what is y in feet? What is x in seconds? It's going to give you feet per second. So this tells us that this particle is moving 8 feet per second. Does that make sense to you guys? So far, it didn't make sense? Yes. So here's how it looks so far, more or less. Don't worry. Maybe it's because you're visual. See how it says 2t squared minus 1? So here's what you guys did. So here's a graph, more or less. 2t squared minus 1, it looks something like that. But it only, well, okay. Let's pretend that t is greater than or equal to 0. So I don't have the left side. So I just have something like this. And then what you found, let's see, at 2. What you found is this. So I'm going to say 2 is right there. You found that slope. You see that blue line? The slope of that blue line is my speed. Slope of blue line is speed at tangent point. That tangent line gets steeper as you move the point of tangency. Does that make sense? Yeah, I'll say it again. That tangent line gets steeper if you move the point of tangency. So that green dot that you see that I'm zooming in, that's my point of tangency. If I were to move that green dot more to the right, it would get steeper, my slope, my tangent, and because it's getting steeper, that means the speed is getting faster. Yes. Point of tangency. Like here's my point. Tangency.
Tangency, one word.
Yes.
Oh, okay.
Point of tangency. Are we feeling okay? All right, so here we go. Look at example 7. We got a physics question. A rock breaks loose from the top of a tall cliff. The position function of the rock is f of t equals 16t squared. We're going to talk about that in a little bit, where that came from. Feet, where t is in seconds. This formula does not comes from somewhere. It didn't magically appear. What is the average speed during the first 2 seconds? Okay, before I even start, in math, a lot of times they don't give you the formulas. You have to find them. But luckily, the calculus AP exam, they're not testing to see if you can. They're testing to see if you know calculus. So they will probably give you the model, but they don't have to. Are we clear? That 16t squared did come from somewhere. Let me tell you where it came from. Do you remember when you were in physics, you had this formula? You had, let me see, how did it go? Your change in position is equal to velocity initial times time plus 1/2 acceleration times time squared. Do you guys remember that? Okay. If something is falling, a rock breaks loose from the top of a tall cliff. So that means, what was the initial velocity? Yeah, initial velocity was 0. So that means this goes away. And then acceleration due to gravity, instead of 9.8 meters per second, we're in America, we're going to use feet per second. Guys, that was a joke, but if I offended you guys, I'm sorry. It's 32 feet per second squared, gravity. Yes or no? What's half of 32? OMG, look, 1/2 AT squared, 16t squared. So that formula came from that physics formula that you guys have been using for 2-3 years now. Cool or not cool? The acceleration due to gravity is 32 feet per second. No, it's 9.8 meters per second. In the metric system, it's 9.8. Yeah, per second squared. Sorry, what? It's 9.8 meters per second squared. That's in meters per second squared. But if you convert meters to feet, it's 32 feet per second squared. Oh, that's always given. It's a standard thing. I mean, I guess if you're on top of a mountain, it might be less. But, assuming everything ideal, 1 atmosphere, on sea level, 9.8. Cool? Okay. All right. Are we okay so far, guys? All right, here we go. Sorry, I'm trying to erase everything here. Come on, buddy. All right, here we go. What do they want? What is the average speed during the first 2 seconds? So I'm going to go ahead and just give you the average speed definition like you did in physics. Average speed is just displacement divided by the change in time. Displacement divided by time is average speed. Well, if you want to, it's the same thing. Velocity is a vector, speed is a scalar. Are we still okay, guys? All right, so here we go. I want to find out the displacement of this rock within the first 2 seconds. Obviously, so here's what I need. I need f of 0. 16 times 0 squared is 0. That's my position initially. And I need f of 2. 16 times 2 squared. 2 squared is 4. 16 times 4, is that 64? Yeah. Okay. Are we still okay? So my displacement. I always like to do final minus initial. So f of 2 minus f of 0. And I know that f of 0 was 0. So divided by 2 minus 0. So 64 minus 0 divided by 2. What is 64 divided by 2? So my average velocity or average speed is 32 feet per second within the first 2 seconds. Does that make sense? Yes. Why is 1 not squared? The change in time is just 2 seconds minus 0 seconds, so I'm not multiplying it by anything that would make it squared. Maybe you're thinking about acceleration. Acceleration is the change in velocity divided by time, and that would be multiplying time by seconds because you got meters per second or feet per second divided by second, which is feet per second squared. Are we okay right now, guys? Okay. 32 feet per second. There it is. Not a big deal. We're good. All right. What is the speed falling at the end? Look at this one. This one's asking something different. And notice there's a lot of white space. What is the speed of the falling rock at the instant t equals 2? So they want to know. They don't want to know the average. They want to know at that moment. So here's what you're going to do. It's a hack. Well, it's not really a hack. We need f of 2. F of 2 is still the same thing. 16 times 2 squared, which is 64. And then we need to know a little bit past 2 seconds. So I'm going to write 2 plus h, where h is just a little bit past 2 seconds. Does that make sense to you guys? 16 parentheses, 2 plus h, close it, squared. I'm going to expand it. 16 parentheses, 2 times 2, 4. 2 times h is 2h. You're going to have how many of those? So 4h. Yeah, 2 of those, so 4h. No, you're right. H times h squared. Let's go ahead and distribute that 16 there like so. So 16 times 4, 64 plus 64h plus 16h squared. Is everyone okay? All right. Here's my hack. Yeah, ask. Remember that this tells me my position of the rock, right? So the only way that I can find my instantaneous velocity, the only way I can find my average speed, well, speed is displacement divided by time. So here's my final position, 64 plus 64h plus 16h squared, that's a squared, minus my initial position, 64, divided by 2 plus h minus 2. That's my change in time. Yes. Oh, well, I said f of 2 and then a little moment past 2. Yes. Are we still okay, guys? All right. Give me your A game, guys. Give me your A game. All right. The only way we can get the instantaneous velocity is if h approaches what? 0. I need it to approach, let me tell you why, guys. I need it to approach 0 because I want to know my instantaneous velocity or speed at 2 seconds. Not at 2.1, not at 2.2, not at 2.5, right at 2. And if I make h approach 0, well, 2 plus h minus 2 is going to be my h, like my change in time. Does that make sense? I'll say it again, just because maybe I'm confusing you with my words. Position final minus position initial divided by the change in time. I need my change in time. I need it right at 2 seconds. So in the bottom, if I make h approach 0, the 2's are gonna cancel out. I'm gonna get h. I cannot do direct substitution, but with smart algebraic manipulation, I can get a number out of this. That's what I'm trying to say. Are we okay? So we're still doing final minus initial over change in time. Doris, you okay? For sure. Ask, please. What? Yeah, initially. But if I do algebraic manipulation, I will not. So here we go. So maybe I explained it wrong, or not wrong, but like too much. So here it is. I'm going to go ahead and approach 0. 64 plus 64h plus 16h squared minus 64 over h. Remember that h is just a change in time in this case. I'm going to zero out what first? The 64th. And now what can I factor out in the numerator? An h. And notice, Gonzalez, that now that I factor out the h, I can now do direct substitution. See how the h's cancel out? What is my speed at the moment t equals 2 seconds? 64 feet per second. You cannot do this. You cannot do this type of physics without doing the calculus. It has to be done with limits or derivatives, but we're not there yet. Oh, because I wanted you guys to see where it came from. This is my time final. This is my time initial. And remember that this is supposed to be my change in time. So 2 plus h minus 2, the 2's cancel out and you just get h. I don't want you to be a robot because you could very easily just, I don't know what Chavez did, but I know it's always the same equation. F of 2 plus h minus f of 2 all over h. And you just start doing that like no one's business. And you're like, why? Like, I don't want you to be a robot. I know that you can be a robot, but I don't want you to be a robot.
So on the line where we have the 2 plus 8 minus 9, we just subtract the 2 from
that 2 and that 2 zero out. Yes. All Are we okay so far, guys? Check it out. Now we're in Mars. So according to this, the gravity of Mars in meters per second. Someone do a quick Google. What's 1.86 times 2?
Mr. Chavez,
Yes,
can
ma'am.
you please post your ticket?
Yes, ma'am. 1.86 times 2. Okay, so someone go to Google real quick and put gravity of Mars and see if it's 3.72. Okay, so there it is, guys. Did you guys hear that? This equation came from somewhere. It didn't magically appear. This is telling me that gravity at Mars is 3.72 meters per second. And Lopez just verified, according to Google, it is 3.721 meters per second. Oh, we're not. We're going to leave it. Don't be converting meters and feet and blah, blah, blah. So whatever unit they give you is the unit they give you. All right. Are you guys ready? Find the speed of the rock at 1 second. When it says when it's written like this, they want instantaneous velocity at 1 second. So here's what you're gonna do: limit as h approaches 0. H is like your change in time of f of 1 plus h, a moment past 1 second, minus f of 1 divided by h. Are we okay with that formula? All right. On the side, I'm going to go f of 1, and I'm going to go 1.86 times 1 squared. And you get 1.86. So at 1 second, you're at position 1.86 meters from your starting. A little bit past 1, so 1 plus h, I'm going to go ahead and 1.86 times 1 plus h, close it squared. I'm going to expand it. So 1.86 times 1 is 1. 1 times h is 1h, but you're going to have how many of those? So 2h, and h times h is h squared. Distribute the 1.86. 1.86 plus 3.72h plus 1.86h squared. Yes, miss. Well, I don't want it at a little moment past 1 second. I want it exactly at 1 second. Because the only way that we know how to calculate average speed or average anything is displacement divided by time. So a little moment past 1 second minus f of 1 divided by the change in time, that's speed. And then we're going to say, all right, the change in time is going to approach 0. Does that make sense?
So you're trying to do it in a way that's...
It's a hack.
Oh, okay. Okay. I was wondering. I was like...
It's a universal hack. This is how Newton did it. This is how everyone's done it. And then they found out a pattern, and then they started doing patterns, which we're not there yet. We're almost there. Here we go. Limit as h approaches 0, 1.86 plus 3.72h plus 1.86h squared minus 1.86, all divided by h. Let's zero out some stuff. The 1.86 zeroes out. Can I factor out an h? So here we go. One more limit. Limit as h approaches 0. There's my h. 3.72 minus 1.86h. Excuse me. All over h. 8. Oh, did I put plus? Okay. I'm still going to get the same answer. Sorry. Because that has an h, so it's going to go away. H's cancel out. H is approaching 0. So my answer is 3.72. I need units. Meters per second. That is not the acceleration. That is the speed at the moment. T is 1 second. Yes. Yeah. But it's calculus-based physics, so it's different. Yes. Oh, is that too? We can calculate. So we can calculate speed. Speed is displacement divided by time. So I need to know my position a little bit past 1 minus f of 1, that's displacement, divided by the change in time. You know what I mean? And then I made the change in time approach 0, which gave me my instantaneous velocity. I need my change in time to approach 0. Because I want it right. No,
I get the first part.
Okay, so this. Okay, so you get the top part, the numerator, right? Position final minus position initial. And in the bottom, I have time final minus time initial. 1 plus a little bit past it, minus 1. The 1's cancel out, and I just have h. I want h to approach 0 because I want my change in time to approach 0. I want my speed right at 1 second. So because I want it right at 1 second, if I have 1 plus a little bit past it, minus f of 1, you know what I mean? Like, I need my change in time to approach 0 so I can be right at that 1 second mark. Does that make sense? And then I don't have a polar system, but let's see what it says. If the graph of a function has a tangent line at x equals a, then the graph also has a normal line at x equals a. Justify your... Okay, if you have a tangent line, does every tangent line have a normal? Yes. Always. Every tangent line has a normal. True. Every tangent has a normal.
But wouldn't it be, sorry, if the normal is a perpendicular, what would it be like x equals negative 1 up a?
No, well, if you have a tangent line that is horizontal, then my normal line is going to be vertical. So it's going to be x equals whatever. Okay, say it again. Oh, my tangent line and vertical line meet at the same time value.
No, but like, what if this one be y equals something?
If it's a horizontal line, yes.
Okay, well, so basically, x equals a is giving you what the point on the x-axis at which you have a tangent line. So let's say a is the point.
Yeah.
So let's say a is the point. So at x
It says I have a tangent line at x equals 2, then I also have a normal line at x equals 2. That 2 is where they both, that's where they intersect. All right, number 2. I think this one was a part of your homework question. I don't remember. X squared plus x. Find the average rate of change of this function over the interval 1 to 3. We can give this question right now to Algebra 2 kids, and they should be able to figure it out, maybe. Right? Because they should know average rate of change. It's just change in y over the change in x. So here we go. I need to do f of 3 minus f of 1 divided by 3 minus 1. On the side, I go f of 1 equals 1 squared plus 1, so I get 2. And then I'm going to go f of 3 equals 3 squared plus 3. So 9, 10, 11, 12. I get 12. Here we go. 12 minus 2 over 2. So I get 10 over 2. So I get 5. Everyone see how we did it, guys? All right. Here we go. Which of the following is an equation of the tangent to the graph of f of x equals 2 over x at x equals 1? So here we go. They want a tangent line. I need two things. What and what? A point and a slope. Do I have a point? Yes, I can get it. So x equals 1. So here we go. F of 1 equals 2 divided by 1. So 2. So my point is 1 comma 2. Yes, miss. If they don't give you a point, you cannot find a tangent line. They have to give you a point to get a tangent line. You can't pick whatever. They have to give you a point to find a tangent line. Because I have a curve. So look, I'm just saying, look how 2 over x looks. It looks like that. And x equals 1 is like right here. So maybe, because you guys are smart, you guys are like, well, at x equals 1, here's my tangent line. And because you guys are smart, you'll probably be like, delete, delete, And maybe you'll figure it out that way. Let me see. Delete. So now it's between C and D. You see how we did it? Because my tangent line has to look like that, so I have to have a negative slope. It's not going through the origin. So I have a y-intercept. I have a negative slope and a y-intercept that is positive. So maybe you do that, but if you have a tangent, all tangent lines, they must give you a point, or at least a starting, but they have to give you something. Say it again. Okay, here we go, guys. I need to find my slope. My tangent slope is limit as h approaches 0. You guys already know what I'm going to write. F of 1 plus h minus f of 1 over h. Don't be a robot. It is the same formula over and over again. Don't be a robot, though. Make sure you know where it comes from. Are we okay? All right. I already have f of 1. F of 1 is 2. I need f of 1 plus h. So I'm going to write it here on the side. F of 1 plus h is nothing more than 2 over 1 plus h. Leave it like that. Here we go. Limit as h approaches 0. 2 over 1 plus h minus 2. All this over h. Oh no, Chav, I can't do algebra. Yes, you can. Yes, you can. I need a common denominator. I'm going to multiply this 2 over here on the right by 1 plus h over 1 plus h. So here's what you're going to have now. Limit as h approaches 0. 2 over 1 plus h minus, and I guess we can distribute like that. 2 plus 2h, and a little bit I'll distribute the negative, guys. Over 1 plus h, all over h. I'll zoom in. Now I'm going to distribute the negative. Limit, and I still haven't evaluated it, so I got to keep writing limit. 2 minus 2h over 1 plus h. I'm going to put it in parentheses, and I'm going to pick that h up and put it right there. Can I do that? Okay. Yeah, keep, change, flip. I can't do that. Side note. A over B divided by C. So notice this is like C over 1. I can do keep, change, flip. Keep the A over B times 1 over C. So A over BC. So I could have just put that C right there like that. See what I did there? Okay. Stay there? Okay. Is all this making sense? Okay. Don't cancel out the h until you zero out everything that does not have an h. What cancels out in the numerator? The 2's. Now, can you cancel out one of the h's? What is h approaching? 0. So you have negative 2 divided by 1, which is just negative 2. Do I have enough for a tangent line now? Yes. So here we go. Let's answer the question. I guess the only one that has a slope of negative 2 is this one. But I want to do it the right way. So here we go. Y minus 2 equals... Oh, I never took attendance. I'm sorry, Ms. Corpus. I'm on it. Go ahead and solve for slope and intercept. I should just give one of you guys my pen. Just don't change grades and take attendance. No? Okay. I trust you guys. Yeah, no, I'm just going to give you my laptop and say take attendance. But don't change grades. Just, here we go. Y minus 2 equals negative 2 parenthesis x minus 1. That's the answer. Can you make it look like negative 2x plus 4? Yes, you can. Distribute the negative 2. So y minus 2 equals negative 2x plus 2. And then go plus 2 plus 2. OMG, y equals negative 2x plus 4. Yay or nay? Yay. Plus 4. Yeah, these are the worst answers of the Kareem. The y equals negative 2x and the y equals 2x are the absolute worst. You do not, a rational function that has a vertical asymptote at x equals 0 does not have a tangent line going through the origin. It's impossible. Impossible. Okay, sorry. I got triggered there. I didn't get triggered, guys. All right, here we go. This one should be easy. It says they want the normal line now. It's the same point. How do I find a normal line? Opposite reciprocal. What's opposite reciprocal of negative 2? Positive half. Y minus 2 equals a positive half. X minus 1. Turn that into one of those. Y minus 2 equals 1 half x minus 1 half. Add 2, add 2. So y equals positive 1 half x. 2 minus a half, is that what? 3 halves? 3 halves. Two. Yeah. That 2 is 4 over 2. Are we good? We did it? Is that the last? All right, let's look at your activity. Copy. What happened? These are all the problems that these are all the notes we've already done in all the classes. Where's paste? Did I not push copy? Paste. Okay, there it is.
What software do you write,
This one. It's called Drawboard PDF. It's like $5. Yeah, $5.
Oh.
No, 5. I would not pay $500 for a dropboard annotation.
Because, well, I annotate from when you have like
Directly on the PDF?
Yeah,
Yeah, you can do
save that.
Yeah, you can do that. I just like to have these little options here on the side. All right, guys, which one's giving you a hard time? Number 8. At what point is the tangent f of x equals x squared plus 4x minus 1 horizontal? I like it. Oh. When you have what slope do you have when the line is horizontal? 0. So all you got to do is go limit as h approaches 0 of f of x plus h. You're going to have it in terms of x minus f of x all over h equal that to 0. So find that expression. You already have f of x. Get f of x plus h. X plus h squared plus 4x plus h minus 1. Go ahead and expand it. Do all that stuff where you cancel out stuff. And you're going to get an expression just in terms of x equal that to 0. Solve for x. And at those values, is where you have horizontal tangents. That makes sense? Okay. Let's see how smart you guys are. So don't worry. Come back to this one later. I just want to test you guys really fast. Look at number 9. Find the instantaneous rate of change of the position function y equals f of t in feet at the given time t seconds. Number 9, without even, well, thinking a little bit, but not thinking hard, can you tell me what the answer is right off the bat? What is it? Number 9? It's not -4. It's not -7. It's 3. What is my rate of change of this function? What's my rate of change, guys? Is it always 3? Does it ever change? It is always 3. Now, let's do it together. If I do this, limit as h approaches 0 of f of 1 plus h minus f of 1 divided by h, I guarantee that it's going to be the number 3. Because remember, all this means is tangent slope or instantaneous rate of change. My slope is always 3, so I better get 3 all the time. So look, f of 1 equals 3 times 1 is 3. 3 minus 7, what's that? 7, 1, 2, 3, -4. And then f of 1 plus h is 3 times 1 plus h, that's an h, minus 7. So 3 plus 3h minus 7, so -4 plus 3h. So here we go. Limit as h approaches 0 of -4 plus 3h minus of -4 all over h. Notice the 4's cancel out because that turns into a positive. Now don't worry guys, I'll slow down. We already know that this is going to be 3, that's why. Limit as h approaches 0, factor out, well, there's nothing to factor out. There's just a 3h over h. 3h over h, the h's cancel out, and you always get 3 for all values. Yeah, for number 9. You guys see that? How do we feel? All right, 10's not going to be, that one you have to do. Yeah, they have different slope values and different values. 11 you got to do. All right, guys. 6a. So I want the slope of this curve at x equals 1. So I need to do limit as h approaches 0 of f of 1 plus h minus f of 1 over h. I'll just get you guys started. F of 1. 1 squared minus 4 times 1. So I see -3. You did, no, I mean, that one's a tangent line, the equation. But some of that work could have gone over there. So all you're doing is, so do f of 1 plus h, 1 plus h squared minus 4 times 1 plus h. And this is what you're doing on this one. Limit as h approaches 0 of whatever you get when you expand that minus -3 all over h. And you get, like, expand it. 1 plus 2h plus h squared minus 4 minus 4h. Expand this. Like you do.
Oh, okay. I thought you were doing it for the list.
Any other ones? I want you guys to keep going on that one. That's yours. It wants a slope at x equals 1.
Oh, yes.
No, you're good. Ask. What's going on, Tovar? Torres. Okay, come on, guys. If you need a break, take a break, but make sure that we get back on Math Life. D, print it out, yeah. Just go to the library. I mean, you can draw it, but make sure that it looks like a tangent, and it looks like the curve, and it looks like a normal. There's no library here?
I mean, there is, but like, there is always. No, it's not. I go there much all the time.
Clark Rankin?
There's Clark
Rankin?
Oh, Cartier.
Why don't we just print it all around paper? What do we